So good afternoon. It's really a pleasure to be here presenting our work on micro-LED display. When I started to work in display industry, people say, oh, why are we here in semiconductor field, like SEMICON Taiwan? And so I have to explain this. What we are working on is compound semiconductor devices, like very small size LEDs. And those devices can be applied to display applications or others. I'll describe more about that. And so I do want to say that micro-LED is, in general, a really combination of display and semiconductor industry. So again, we try to do as much as we can to enable different kind of possibilities. So this is the agenda today. Let me first introduce a little bit the status of micro-LED technology or micro-LED display industry. So as you can see here that we first launched micro-LED TV with Samsung Electronics 2 years ago. And if you go to the department store, this is our president, Jovi. So if you go to department store in Seoul or in Korea, then you can buy the TV there. You can actually go there and take out your credit card and say, okay, I want to buy this TV, and then you can buy it. Of course, in general, a normal credit card cannot really afford that. Probably you need some special card, like black card from American Express. So in general, it's still a very expensive product, but it is really on the market right now. And we do believe that in the very future time that micro-LED TV will be an important product, especially for premium TV technology or even like indoor, outdoor commercial display. So this is what happened. And after we launched that TV, people normally say, oh, Charles, this is too expensive. We just cannot afford it. And normally I told them that, please wait a little bit because something's coming up. And so what happens last year was, I talked to people, please trust me that the watch is coming. The watch is coming. And, but even in the beginning of this year, it's still, we don't see that get released. And I have to tell you that to do a research is one thing. To do some product development is one thing. To really make something new into production is very different. And this is what we suffered. So we actually supposed to see this product in the market end of last year and beginning of this year, June, July, August. And finally, just a few days ago, when I prepared this talk, I don't even know if I can say that, but so just 3 days ago, so Garmin released probably the first micro-LED watch in the market. So if you go to any shopping website, like PC Home in Taiwan, Momo in Taiwan, or Amazon in the States, then you can really buy this. And I think the price is, I would say it's reasonable, about $2,000 US, which is, I think someone can afford that. But anyway, this is really a big milestone for us. And I have to tell you that something more, they're coming. But before we move to the next topic, I would tell you that if you just take a look at micro-LED watch, OLED watch, and LCD watch, you'll easily see the differences. Compared to, when OLED comes up, some people say, oh, this is OLED iPhone, this is LCD iPhone. I cannot tell the differences. But today, if you go for micro-LED display, you really see the differences. Not only just the prices itself, but the performance as well. Yeah. So next one is the one we believe also coming very soon in the future. This is transparent display. And people wondering how to use transparent display. And by the way, when we say transparent display, we have a definition. It has to be transparent first. And the transparency in general has to be higher than 50%. For MicroLED, we can easily do 70% transparency with very high brightness. So if you go for OLED, OLED can do a little bit transparent display with about 45% transparency and brightness less than like 500 nits. But we are talking about MicroLED transparent display, 70% more transparency, and with more than 10,000 nits. So we can easily use that for automotive display. And believe it or not, I really cannot say I'm sure, but believe it or not, we'll see this MicroLED display coming to automotives very soon, or I would say even by the end of this year. We probably will see this on a production car. So also, if you look at PlayNitride, the company, we were supposed to be defined as a startup company, and we do something very different from what we used to do. We have a very fast growth rate, and last year we actually achieved a milestone that the annual yearly financial break-even, which is a very important milestone for a startup company. And we do believe that this industry is very promising, and it's coming better and better. So if you ask me about what's the status for MicroLED industry, I would say it's very, very positive. But of course, there are many, many things to do, and we do believe that more applications is coming up. So when I do this preparation, I understand this is a compound semiconductor forum. So I'm not sure if everyone understands what is exactly MicroLED. So what I want to say is MicroLED is LED, but it's a very small size LED. And so the fundamental of MicroLED is very similar to conventional LED. But just like semiconductors, when we were doing, earlier times, like 28 micron, 32 micron, to today's 2 nanometers, 1 nanometers, we see a lot of different things we have to overcome. And this is what we have to do. But first, we have to, when we make those very small size LEDs, we have to basically overcome the efficiency issues, the size issues. But after you can make it, you still need to put it onto a backplane. So MicroLED itself, it doesn't really light up until you give it the currents. And the currents is supposedly from the backplane, like TFT backplanes or PCB backplanes. You have to put all these LEDs very precisely onto a backplane. And I will show you that the precision is actually a little bit even more advanced compared to what we are talking about, the CoWoS technology today. After you can do that, you make a MicroLED array, and then it started to become like display. So we have flip chip type, we have vertical type, and this is a typical flip chip type LEDs. We have 2 paths on the same side, and then we have to do flip chip bonding on the backplane with very fast, very efficient technology. And also we can do vertical chip, so the pad will be on 2 sides, and we can also do this bonding. Also, we have to put another contact layer after we do this array. And so what I want to say is industry like MicroLEDs, it doesn't really exist before, and we don't know how to do the sales when we started to make these products. We have to talk to customers, and finally, we understand that there is a chance if, first, we do this arrangement, all these MicroLEDs, these compound semiconductors, onto a temporary, kind of like a template substrate, and with very precise arrangement. So our customer, they don't need to do this. This is the so-called chip-on-carrier product. So we started to sell this, and our customers can now use that. And the term COC, chip-on-carrier, becomes a standard term today, which invented by PlayNitride. And so, again, this is not that trivial. I mean, you probably think, oh, I can understand that. But think about this. First, to put this very small size compound semiconductor devices onto a template, And you have to deliver or ship this wafer to your customer. They have to pick it up without any problem, or I would say 100% they need to pick it up. But during the shipment, you have to guarantee that it doesn't fall off from this template. So we actually developed a lot of different technology to make sure this is happen. So we have tether type structure, we have non-tether type structure to make sure this chip can hold it there for all the shipment. And when our customer use that, it's not really hard to take it off. And we do, after the COC process, we also do this COC2 process to help our customers to do a more advanced arrangement of these LEDs. And so today, if you go to the booth, 4th floor, this building, we actually demonstrate our system there. We can do mass transfer with the systems. And today, it's more than 10,000 chips, actually 100,000 chips per second is achievable. And so this is booth Q5258. If you visit there, probably if there's a chance, we can give you some souvenirs based on this equipment. And so what I want to say is not only just watch, not only just TV, not only just automotives, we still see many new things coming up. One very good example is the AR glasses that we believe will change the world with artificial intelligence. So, you know, it happens many years ago when we just started the company. We talked to many big guys. They said, oh, we want to make super good AR glasses. Maybe you still remember a few big names. They have whales jumping out of a gym, and then they believe this is coming up. But then they're just gone. And today, it becomes very different because when we decided to go with them, they say, oh, we need to make perfect goggles. They can do so many things. And finally, it becomes a very strange goggle there. But today, people ask for stylish and fashionable for their AR glasses. They don't want to see this kind of thing, or you don't want to wear this on the street. So what happens is the new technology coming up with, they ask him for as small size as possible. So today, the goal is to make a light engine less than 0.5 cubic centimeter. And so we keep developing very small size displays, 0.18 inch with more than 5,000 ppi, RGB displays. And we started to work a lot of improvements with different color gamuts, with different pixel EOs. Today, for us, we can easily do 99% with the chip itself. But of course, we have a lot of different challenges, which is similar to what we know about CoWoS today. First, we do this die-to-die bonding. And die-to-die bonding, we need a very high precision for the bonding itself. We need to make it, as you can imagine, very small size with very high efficiency. So today, we deliver many of our micro displays to customers with, in general, the EO higher than 99.5%. And this is not easy. So let me tell you what we are doing. We need to do these LEDs which were supposed to be on sapphire wafers. And then we do all the process, like semiconductor process. And then we also need to do a CMOS backplane. So we work with IC designers, we work with foundries to make those CMOS panel. And then we do the bonding. And the bonding is supposed to be very, very precise. We're talking about the precision error less than 0.5 microns. So if you look at the comparison, as I mentioned earlier, to the CoWoS packaging technology, today, micro display, we are talking about the micro bump size, less than 3 micron. And compared to, in general, CoWoS, of course, CoWoS is getting smaller and smaller, but 20 to 30 micron. And the alignment accuracy is actually, we have to be within 0.5 micron, and also others. I would say micro-LED process is very similar to a very advanced CoWoS technology. And I would say even probably more advanced. So we have developed so many, and still we believe there are more for the future of micro-LEDs. First, if you look at this, all the benefits of taking micro-LEDs, we have very high brightness, we have very high modulation speed, we have super good integration capabilities, and we also have very small size. Then what we can do today, we are talking about optical communication. We're talking about by using this by light communication, visible light communication, and we can do this advanced packaging with micro-LED technology. We can also think about using micro-LED mass transfer technology for a touch sensor for the skin of robot. So these are happening right now with what we are doing today with micro-LED technology. So in conclusion, I think micro-LED is really getting more and more matured. Earlier times, people talk to me when we'll see this in the market, and I can tell you that it's already in the market today, and we are not just talking about how to make it. Today, if you ask me, what I worry today is the capacity. We are talking about how to make more, how to make our customers to be satisfied with the capacity. And besides that, we do believe, we actually see a lot of different kind of possibilities for the future that we have never imagined before. We do believe that micro-LED will really enable a different world. Thank you very much for your listening. Thank you.
Now it's open for question. Any questions? Okay, I have one.
Sure.
If you want to use micro-LED for the light source for CPO, so do you see there is another light source, right, that we sell? So what is the benefit of micro-LED?
Okay, that's a very good question. The question is regarding why bother using micro-LED instead of just using laser itself. I think the modulation speed is wise. Laser can be faster, of course, but I think the goal is to be higher than 1T, maybe. And if you use micro-LED itself, we need to overdrive micro-LED very much similar to the current density of laser to make it higher modulation speed. But if we're talking about maybe 200G for the speed for each micro-LEDs, or 100G. But if we have 10 at the same time, then we achieved 1T. Today, people are talking about maybe 200 or 500 micro-LED as an array to connect it to the optical fibers. So you can easily achieve the goal for AI servers demand, much higher than conventional laser-like scheme. But I'm not saying that this is going to replace what we have today, but maybe there's a chance for future if we really need higher bandwidth or much faster one. This is a chance. I do believe this still, it's under development, but still needs some time to be matured.